Today we are looking at transformations of the sine function. So specifically, we're going to look at our negative d and our plus c for our sine function. Okay, so if you remember from your grade 11 math course, there's a whole bunch of things that we did to our quadratic function, which was our parabola. So we moved our graph horizontally, we moved it vertically, we stretched it vertically and compressed it vertically, and then we had vertical reflections. Okay, so if you remember that, here's something that looks a little bit bigger. This A out front is our vertical stretch or compression. Okay, so it's going to make your graph look like tall and skinny or short and narrow. Okay, this H is our horizontal translation. So we're moving our graph left and right with this one. And the key here is to remember it's always opposite of what you see. So if you see a negative sign, it's actually to the right. And if you see a positive sign, you're actually moving to the left. Okay, and then this K is going to be our vertical translation. So we're moving our graph up or down. Okay, so just remember those, and we're going to actually now apply them to our sine function, and they're actually the exact same except for we use a, you're going to see like f of x, wow, slow again, is equal to a, and then you'll see x minus d, sorry, I forgot the sign. And then you'll see a C at the end instead. So we just use D and C, it's the same thing. D and H will do the same thing, C and K will do the same thing, and then those A's do the same thing. Okay, so we're going to look at it specifically for our graph. So originally in our first lesson, I got you to copy this out. You should have your 5 main points that you have memorized how to draw on the graph. So if you start with a table of values, you're going 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And then it's starting at 0, going up to 1, back to 0, negative 1, 0. So 0, 1, 0, negative 1, 0. Okay? You will see here that we want to move our graph down 3. It's not in brackets. It's not x plus or minus in brackets. It's outside of the brackets. So that is a minus c. Okay? So we're going to move our graph down 3 units. Okay? So for this, it's actually quite easy. You could just take, rather than going to 0, 0, you're going to go 0, negative 3. So you're just going to take that dot and move it down 1, 2, 3. This dot at 1, you're going to move it down to 1, 2, 3, down to negative 2. Same thing here, down 1, 2, 3, down 1, 2, 3, and then down 1, 2, 3. So you get those 5 new dots that are down 3 units. Okay? I will also show you on a table of values. So since you're moving it up or down, that's your y-axis. So it's going to affect your y values. So why I'm going to show you on a table like this is because what happens if you move your graph up and down, you move it left and right, you stretch it horizontally, you stretch it vertically, and you reflect it. Okay, so what happens when you have all of that happen is it's easier to keep track through a table of values and then graph the final, so you don't have like 5 or 6 different graphs on one grid paper. Okay, so because you're moving it down, we would write down 3, and then all that means is you're going to subtract 3 from each of these y's. So 0 minus 3 is negative 3, 1 minus 3 is negative 2, 0 minus 3, negative 3, -4, and then -3. Okay, this gives you new ordered pairs. So your ordered pairs that you would graph would be 0, -3, 90, -2. You don't need to write these ordered pairs out. You can just read them from your graph. 270, -4, and 360, -3. So what I could do is go 0, -3. Oh, there's a point. 90, -2, put a point. 180, -3, put a point. 270, -4, put a point. And then 360, -3, put a point. And then I would connect my dots. Okay, so it's easier for these ones to just move our points down for this lesson today. But when we start to combine our transformations in lesson 4, you will want to use a table of values. Okay, but so that's why I get you comfortable with it today. I'll do it for every graph that I show you. Okay, so on to our next one. We are going to go from sine of x, which is our green graph, to our black graph, which is sine of x minus 60. So you'll notice this time it's in our brackets. Okay, so it isn't a d. Our d moves our graph left or right. But remember, because you see a negative sign, we're going to go right 60 degrees. Okay, so it's opposite of what you see. So you think that you would move left because it's negative, but you're actually moving right. Okay, again, you can find, so here's your original graph, 0, 0, the scale's off a little bit, remember that as well, 0, 0, 91, 180, 0, 270, -1, 360, 0. And what you're doing is you're just taking each of those points and now you'd go over 60 degrees. So this one is going to come over 60 degrees. This one is going to go over 60 degrees. This one is going to go over 60, over 60. And then because your graph only goes to 360, we actually can't graph that last one. It would be over at 430. Okay, so what you can do though, so even some people might not be comfortable with that. So what I'm going to do is get you to do your graph or your table of values again. So always again, you'll get tired of writing the same starting table of values, but you know it's going to be the same every time. Okay, now because we're moving left and right on a graph, that's our x-axis, not our y. So we're going to draw a line on this side. And because we are going to the right 60 degrees, we're going to add 60. Okay, so you're going to go 0 plus 60 degrees is 60 degrees. 90 plus 60 degrees is 150 degrees. 180 plus 60 is 240, 330, and then 430. Nope. Yeah, 430, 420. Sorry, I did my math wrong in my head. Okay. So you're going to go and now plot those points. So your new points are 60 and 0, 150 and 1, 240, and 0, 330, and -1, and 420, and 0. Okay, so you kind of, if you write anything to the left, you ignore that left column, and then you haven't done anything to your y column, so you use that y column still. Okay, so that is graphing there. So you could see we're going over 60, 0, and then we're going over to 150 up to 1, 240, 0, 330 down to -1. And then if our graph went further, we could graph that last one. Okay, so starting a little bit more simple with these two graphs, and now we're going to get into one that we do both. Okay, so take a second just to step back for this. We're starting originally with our green graph, which is just our sine of x. So you should notice the 0, 0, 91, 180, 0, 270, -1, 360, 0. Okay. Then they have translated it to the left 45 degrees, and then they've moved it up 2. Okay. If this looks chaotic to you, again, I'm going to show you that table of values to help it make more sense. Okay, so again, 0, 90, 180, 270, 360, 0, 1, 0, -1, 0. Okay, so let's start. We're going to move our graph. So that sine of x plus 45 degrees is going to be to the left 45 degrees. Left is always going to affect your x's, or right as well, so you're going to move it to the left, so we're going to subtract 45 degrees from each of these, okay? And then our y for our final one, which is plus 2, so g at x is sine x plus 45 degrees plus 2. That plus 2 is going to be up 2, so we're going to take all of our y's and move them up 2. Okay, so now just doing some math here. So you're going to be at negative 45, 45, 135, 225, and 315. So just subtracting 45 degrees from each of those, and then add 2 to each of these. So you're going to be at 2, 3, 2, 1, 2. Okay, so if you use these points, you have new points. So negative 45 degrees and 2, 45 degrees and 3, 135 degrees and 2, 225 degrees and 1, and 315 degrees and 2. Okay, so what you're going to do is, because you haven't marked negative 45 on your graph, which is actually only 2 units, so you could technically put negative 45 there. Okay, then you would be negative 45 and 2, so you could actually make a mark there if you wanted to and extend the graph here a little bit. Okay, then you're going 45 degrees and putting a dot at 3, 135 degrees and putting a dot at 2, 225 degrees and putting a dot at 1, and then 315 degrees and putting a dot back at 2. Okay, so then you would connect all of your dots there. Much neater than I can do on my whiteboard thing. Okay, so that is how you would do it. Okay, you're also allowed to do it if you want, which I find super confusing, especially when we start to get into stretches and compressions. You could have taken your original graph and then moved it to the left 45 degrees first. So you could have moved this dot over here, left 45. This is over 45 degrees. This one over 45 degrees, this one over 45 degrees, and then this one over 45 degrees, and then taken all of those points and moved them up 1. Sorry, I'm on the red graph. Up 1, 2, and put a dot. Red graph up 1, 2, put a dot. Up 1, 2, put a dot, and it kept going. So it depends on what you're comfortable with, but I would get you comfortable with showing this work in a graph, and I'll show you why in the next lesson and the lesson after that when we get into stretches and compressions and vertical and horizontal stretches and compressions, and getting to combining everything. Okay, so here again we're going to figure out how we were able to graph this, okay? So we originally started with our graph 0, 0, and then 91, and look at our scale. It's not very nice, right, to be able to graph that. So if we were at 0, 0, 90 would be about here, and up to 1 would be here, and then we go 180, which is about here, back down to 0, 270, which is about here, down to 1, and then 360, which is about here and up to here. So because of our scale, it's not very nice to draw this, and then imagine trying to move those exactly 30 degrees and up 4 nicely without doing a table of values, okay? So that's why it's easiest to do a table of values, so that you can be very accurate in your points, okay? And your drawing. You need to have graph paper for this unit, or you need to have these sticky pads that you've probably seen them before, that have the grid paper on them. If you want to buy them, let me know, okay? So we are going to look at our equation here. So we have negative 30 degrees plus 4. So this means we want to move our graph to the right 30 degrees, and we want to move our graph up 4. Okay, again, right and left is going to affect your x's, and then that up and down affects your y's. Okay, so because it's right 30, we're going to add 30, and we're going to plus 4 here. So 4, 5, 4, 3, 4, and then 30, 120, 210, 300, and 390. Okay, so then your final points here are 30 and 4, 120 and 5, 210 and 4, 303, and then 390 and 4. Okay, so when you're doing that, you're going to just use those points. So you're going to go over 30 degrees and up to 4. You're going to go over to 120 and up to 5, 210 up to 4, 300 and up to 3, and then 390 and up to 4. Okay, this scale is actually not great. It's from the textbook, so that's why I didn't change it. It's actually not great for this. I personally probably would have went up by either 30 or 60 on my scale, because you're kind of guessing on these, which I don't like. Okay, so make sure that you choose an accurate scale when you're drawing these, and usually it's better to wait until you've done this to know your final points. So you need increments of 30 or 60, like 30 is half of 60, so it's easy to put halfway through a block, right? Rather than trying to guess like a third or like 0.25 of where we are through a single unit on our graph, okay? So another example of what you could be asked to do is it's already graphed, and I just want you to explain sorry, the light turned off in my room. Explain what transformations were applied to f at x equals sine x, which is our green curve, right? We know it's our original curve, 0, 90, 180, 270, 360. Okay, we know that that's our original to create our to create our black curve down here, g of x. Okay, so what is probably easier to do is to find a point. So all of our sine curves have a max and they have a min, right? Okay, so at our max, and then let's find our max here. Our max here would be here. What has happened to our maximum? We have gone over from 90 all the way over to 270 degrees. Okay, what's that difference? Let's do 270 minus 90 is 180 degrees. Okay, let's check our min. So we go from 270 all the way over to 450. Oops, 450 minus 270, again, 180 degrees. Okay, so that is pretty consistent, and like because our graph is periodic, and right, it's not going to change. Like this point isn't going to be 180, and then your minimum is going to move over 800. Like it's going to both be 180. So since we have gone from 90 over to 270, so 90 we've gone over to 270 for a max here, we know that we have a horizontal translation of 180 degrees. Okay, we're moving to the right 180 degrees. So it's better if you put plus here, or you need to write right 180 degrees. Okay, you need to do either of those. Okay, then again, let's take our max point. We have moved over 180 degrees, and we're going and moving it down 1, 2, 3, 4 units. Okay, let's see if that's the same for our minimum. We're moving it over to 450, 180 degrees, and down 1, 2, 3, 4. So you know that you have a vertical translation, down 4. So we didn't write down 4, we wrote -4. So you either need to write the word, or you need to write a plus or a negative sign. Okay, you need to do either one of these, this one or this one. Okay. Then you're going to put it into an equation. So to put it into an equation, you're just going to have f at x. Actually, sorry, it should be g at x, because that's our final graph, is sine, and then you're removing x, and then remember, it's the opposite, so we're going to put a negative 180 degrees, and then we're going down 4, so minus 4. Don't forget your brackets. Okay? Then again, we're going to want to graph our y equals sine of x minus 45 plus 2. So here, we can start with our regular graph, so 0, 0, 90, 180, 270, 360, okay? And then let's make our table of values so that we can translate our final graph, okay? So 0, 90, 180, 270, 360. Again, we're going negative to the right 45 because you see the negative, so we're going to add 45 degrees here, and then our plus 2 at the end affects our y's. Okay, and then you're going to have your final 2 points. So you're going to have 45, 2, 135, 3, 225, 2, 315, 1, 405, 2. Okay, so this one actually shows the movement to the right 45 degrees. So they went over and moved all of their points over 45 degrees. You don't have to show that middle step as long as you're showing the movement up. So then they took all of their points, which were the green, and they moved them up 2. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. Okay, and then, or you could have used your graph or your table of values. So 45, 2, 135, 3, 225, 2, 315, 1, 405, 2. So if you do it with the table of values as well, the way I've shown you, rather than, you wouldn't have to draw this green graph in between to show me that translation. So it saves you drawing an extra sinusoidal graph as well if you use the table of values. Okay? Just a couple more examples here, lots and lots of examples. So our table of values here, let's put our first graph up there, okay? So we're going to move our graph to the left 90, and we're going to move it down 1, okay? Okay, so your final points would be negative 90, negative 1, 0, 0, 90, negative 1, 180, negative 2, and 270, negative 1. Okay, so those would be your final points. Again, here's showing moving all of our points to the left 90 degrees. So this one we would move left, but it's off our screen. Our red one over 90 degrees, our one at 90 over to 0, our one at, our one at 270, our one at 360 over to 270, okay, so and then here as well, okay, so it starts to get a little confusing, even with doing that, okay, but our final graph, let's go to a different pen color. If we were to use these, so we go negative 90, negative 1, which is off our graph, which is fine. Then we're going to put our first one at 0, 0. Then we're going to go 90, negative 1, 180, negative 2, and then 270, negative 1. And then if you kept going, you could add points. Oh, sorry, I forgot. Oh no, 270 -1, yeah. And then the next one would be up to 360. You would move over that 90 degrees and go back up to 0. Okay, so it is going to look like that for our graph again. So you could avoid this middle confusion of this middle graph here. Okay, then one more example. Ooh. I don't know why that went in the middle there, sorry. Oh, because of where the graph is. Okay, we'll just keep it there. Okay, so what we're going to do with our graph is we're going to move it to the left 60 degrees and up 4. So to move it to the left 60 degrees, we are going to subtract 60 from our x's and add 4 to our y's in our table of values. So let's do that. Let's keep it over here. Sorry, I'm going to write over numbers. Okay, so your final points here would be -64, 35, 124, 210, 3, and 304. So you can go ahead and graph those, or I'm just going to have the animations that come up. Okay, so there is our original graph of sine of x. Then they have moved all of the points to the left 60 degrees. So taken here, moved it 60 degrees, here moved it 60, here moved it 60, and up here moved it 60 where I've written. Okay, or you could have just done these final points. So -64 we don't see, but 35, not 360, 35, 124, 210, and 3, and 304. Okay. And then you can continue the pattern if you want. So the next one would be at that 390 back up to 5. Okay. So with that, you are going to complete your homework. Okay. Please make sure that you should have copied all of those graphs out during the lesson and stopped and written all of them out, written all those table of value out. However, I'm writing this here. It is a must. You have to use graph paper. Your assignment and your test that you're going to do for this unit, if you do not have graph paper and you try to draw some graph, I will not mark it. You will receive 0. So you have to go and get graph paper. You need to print graph paper out. If you have a printer, you can print some from online, or let me know if you need sticky notes and I will get you sticky notes that have the graph paper on them. They are $1 though, so you owe me $1 if I deliver them to your period 2 teacher. Okay, so let me know.